Hello again. Hopefully you've been watching all these videos and you're familiar with all those buttons drawn on this silly diagram of a calculator off to the left. We're going to work on normal distributions. So when you hit second vars and you see normal PDF, normal CDF, and INV norm, those are the three functions I'm interested in. INV ORM on this video. The normal curve, you should have done the percentile and empirical quizzes. And standard normal has a mean of 0 and standard deviation of 1. If I wanted to know the area from, say, negative 0.7 to 1.5, the area under the curve, that would be the probability negative 0.7 is less than z is less than 1.5. Normal doesn't distinguish between less than or equal to. It doesn't care because it says that line right there has no width to it. It's just a direction. Because normal is a continuous random variable. So it doesn't matter which way we write it, and math people are lazy, so we always choose the easiest way. To put this in my calculator, I'm going to do second vars, and I'm going to choose choice 2, normal CDF. Maybe I'm going to do that. And now my calculator asks me for a lower limit, an upper limit. It wants to know what's my population mean, what's my population standard deviation, and then it asks me to paste. My lower limit is the negative 0.7. My upper limit is the 1.5. Since I'm working with z-scores, my mean is 0 and my standard deviation is 1, and I just enter on paste. However, when I enter, my calculator goes back to the home screen and I see normal CDF with a parenthesis, and it tells me my lower bound, comma, my upper bound, and it also tells me my mean and my standard deviation. If you're working with an older calculator that doesn't give you this nice, friendly format, you can still do lower bound first, then a comma, upper bound, a comma, the population mean, comma, the population standard deviation. And we hit enter, and our answer is 0.5994 if I round to the 4th decimal place. That's this area right here is 59.98% of the area under the curve. We want to keep straight whether we're talking about an area under a curve or a quantity that lies on this horizontal axis, because 0.5998 would have been right about there. It's very easy for beginning statistics students to get those two numbers confused, and we must keep it straight. What's the increment on the horizontal axis, the z-score? What's the area under the curve, the probability? Well, sometimes we just want to know the probability of z being less than some value. Probability, we have a z-score less than 0.82. If we drew a picture of this, we would want this area. And our normal curve goes out to infinity. So we really want to keep going to negative infinity. But my calculator doesn't have a negative infinity key. So I'll have to make up a really small number. I might say my lower bound is negative 100. That's going to be plenty good enough. As long as I'm at least 5 standard deviations below the mean, I'm probably going to be close enough to negative infinity in most cases. Not always. But negative 100, well, I have definitely overkill here. So my lower bound, negative 100. Upper bound, 0.82. Mean, 0. Standard deviation, 1. Paste. And we get 0.7939 if I round to the 4th decimal place. Likewise, if I wanted to know the probability z was greater than negative 1.42, if we draw a picture of this, negative 1.42 is going to be right about there maybe. And now I want to go off to the right. Now, while binomial wouldn't allow me to do that in the calculator, normal does, because it wants a lower and an upper bound. So now my lower bound, the lowest value that I'm interested in the shading diagram, is negative 1.42. The upper bound, oh, now I want to go to positive infinity. I guess I'll try positive 100. That ought to be good enough. My mean is still 0. My standard deviation is 1. And I get 0.9222 if I round to the 4th decimal place. I said normal doesn't care about or equal to. If I wanted to find the probability z equals 1, technically that's 0. Because that's just that line that has no width to it. But sometimes we have normal random variables, say x is normally distributed with a mean of 80 and a standard deviation of 12. When I draw that curve, now if I want to know the probability that x equals 82, if x is a discrete random variable and I'm approximating with the normal curve, I could say this would be like the probability x was between 81.5 and 82.5. And that's basically what normal PDF is doing. These don't always match exactly. But if I wanted to do normal PDF, my calculator would ask me for my x value, 82. It would ask me for my mean, 80, and my standard deviation, 12. And it would tell me to paste. And again, if you have an older calculator, normal PDF, it wants the x value first, then the mean, then the standard deviation, and you have to get them in that order. It tells me that probability is 0.0328 if I round to the 4th decimal place. What if I did normal CDF from 81.5 to 82.5 with a mean of 80 and a standard deviation of 12? If I round to the 4th decimal place, it comes out exactly the same. However, if we wrote all the digits the calculator shows, the PDF function would have given me 0.0327866643. The CDF function would have given me 0.0327773534. It's just a matter of where the calculator's rounding and its algorithms that it's following. But you can answer the question using either method if they want the probability x is one given value. I think I'll do the INV norm on another video, so these don't get too long.